Chapter 4 is on systems of equations. We just practiced some of them on Pear Deck. So the definition of a system of equations is there is more than one equation and there is more than one variable. So in the case of these ones here, there are two equations and there's two different variables. There's an x and a y. Okay, to determine whether an ordered pair is a solution to a system, it must satisfy all equations in the system, which means it needs to, when I plug it in, it needs to check for both equations. Okay, so just like when we check these on lines, I'm going to do the same thing except there's two equations instead of one. So this is my x and this is my y because the ordered pair tells me x, y. Okay, so I need to check that it works in both equations for it to be a solution. So over here, I'm going to check the first equation. Okay, let's see, x is 3 minus y is 1. Does 3 minus 1 equal 2? Yes, the first equation works. Now, because the first equation works, I need to check and see if the second equation works as well for me to tell if it's a solution to this system. Okay, so now the y value is still 1 equals 2 times x minus 5. Okay, the left side is solved, so let's just work on the right side. 2 times 3 is 6 minus 5. 6 minus 5 is 1. So 1 equals 1 checks. So yes, this is a solution to the system. For example 2, the point is 6 comma negative 1. The equations are y equals 2/3 x minus 5 and 3y equals x plus 4. For this to be a solution to the system, it needs to check in both equations. Okay, so it actually doesn't matter which equation you do first. Sometimes I check the easier one first because if it doesn't work, I know I can stop. Okay, but I'm going to go ahead and just check the first one. Okay, I'm just rewriting it over here so you can see which one I'm checking. Okay, this is x, this is y. So the y is negative 1 equals 2/3 times the x minus 5. Okay, the left side's good, so I'm just going to leave that minus 1 alone. Okay, I like to put the little 1 over here. See, 2 times 6 is 12. 3 times 1 is 3, so 12 divided by 3 is 4. Minus 5, what's 4 minus 5? Negative 1. Okay, so it does work in the first equation. Does it work in the second equation? Y is negative 1. What is x? X is 6. Okay, 3 times negative 1 is negative 3 equals 10. That does not work. So no, this is not a solution because it doesn't work in both equations. It's a solution to only one of them. Okay, if I had checked the second equation first and I could tell it was going to fail, I wouldn't have had to check the first one because I already knew it was going to be a fail. Okay, so the first method we're going to solve systems using is by graphing. And we just practiced this on Pear Deck, but we didn't practice the graphing. It's been a while since we graphed. So when you solve by graphing, you graph both lines and then you find the point of intersection. The point of intersection is the solution because it's the point that satisfies both equations. Okay, so let's practice graphing real quick. Okay, these are in slope-intercept form. Okay, so this y-intercept is 0, 1. Okay, and then remember the slope is the number with the x, so I'm going to rise 3, run 2. So from the 1 up 3 over 2. Okay, and then I'm going to go ahead and draw that line in. I want to make it as straight as possible. If you have a ruler, that's great. Because I'm trying to see where they cross, and if I get crooked, it's hard to read the graph for where they cross. Okay, now I'm going to graph this second line. The y-intercept on this one is positive 3. And then the slope is 1/2, so up 1 over 2. Okay, I'm going to go ahead and draw that line the best I can. Okay, and then I want to look for where the point of intersection. I can see they crisscross around here. I always give you whole number or integer intersection points so that they're easier to find. So this is my solution. It's going to be at this point right here. The ordered pair for this point is going to be x is 2. X is 2 and y is 4. So my solution is 2, 4. Okay, I'm going to go to example 4 and I'm going to graph that one as well and find the solution. Okay, the first equation is y equals 2x minus 5, so my y-intercept is negative 5. My slope is 2 over 1, so I'm going to go up 2 over 1. You might want to do it a couple times if you don't have a ruler. I don't have a ruler. Okay, then I'm going to go ahead and graph the other equation. It's in slope-intercept form. The y-intercept is positive 4. The slope is negative 5 over 2, so I'm going to go down 5. 1, 2, 3, 4, 5, and right 2. Okay, and I can see where they're going to cross, but I have to draw the line, because that's my work. Okay, and then I look for where the two lines cross, hopefully at a nice corner, which is right here. So the x value here is 2. The y value is negative 1. So the solution to the system is 2 comma negative 1. Okay, let's try a couple more, mostly to practice graphing. Okay, so for this one, we have y equals 2/3 x plus 1 as my first line. It's in slope-intercept form, so I can start at the y-intercept as 1, up 2 over 3. Okay, and let me try to draw a nice line. Okay, my second line is y equals negative x minus 4. It is in slope-intercept form because it starts with y equals. This is like a little 1. Okay, so my y-intercept is negative 4. My slope is negative 1 over 1, so down 1 over 1. Okay, let me I'm going to go up and left a couple times so I can try to get this to be straight. Let me draw this the best I can. Okay, it looks like they are crossing right about here. And since I only give you integers, we're going to assume it's right here. Let's see, x is negative 3, y is negative 1. So the solution is negative 3, negative 1. And if I wasn't sure, I could plug my solution in to make sure it checks. Okay, one last one. Okay, let's see. The first line is y equals negative 3x plus 4, still in slope-intercept form. But the y-intercept is 4. The slope is down 3 over 1. 1, 2, 3, 1. Let me do it again to make it a little bit straighter. Okay, now I'm going to go ahead and graph this one. The y-intercept is positive 1. My slope is still down 3 over 1. Okay, I'm going to draw that line as straight as I can. Okay, now the solution is where they cross. Okay, these don't ever cross, and even if I made them longer, they would still never cross, and it's because they have the same slope. They both went down 3 over 1. Since these lines are what we call parallel, and they will never ever cross, this actually has no solution, because no matter how long I extended these lines, they will never ever intersect.